welcome to math. Okay, if you haven't watched the soup reveal video yet, pause this video because I don't want to ruin it for you. Okay, so pause. I cannot believe that the soup fit into the container. Okay, I can't. Number one, when I was looking at the dimensions, 14 by 8 by 5 seemed pretty big. Like 14 is a 2-digit number. And then 8 by 9 by 9, those are all 1-digit numbers. So I don't know, when I really dug into the numbers for of each dimension, the dimensions of each rectangular prism, I would have said, before I did the calculations, I would have said the soup is not going to fit. It is going to overflow that container. There's no way. But spoke too soon. I guess my thinking's changing now. But I think my thinking kind of changed as I was doing the calculating for the volume of the rectangular prisms. Okay, so today we're going to start out with looking at 3 different students' work. And then I have a challenge for you going forward. Okay, so first, student 1. We are going to look at student 1's work. Okay, take a second to take this work in. What do you notice? Maybe what questions do you have as a mathematician? What's something that they did really well? Okay, so something that I really like about this first student is that up here in the upper right-hand corner, they're using multiples as a multiplication strategy. It looks to me that they're doing multiples of 12 in order to solve for the volume. And then I also see down here that they're using repeated addition, 14 plus 14 plus 14 plus 14, to solve for volume. It's really important for us as mathematicians to remember that we have a lot of different multiplication strategies in our tool belt. So when we're proving our calculation, when we're proving our thinking, it's a really great idea that we pull some of those strategies out to make sure that our calculation is precise. So to make sure that we're getting the accurate answer, and so that we can really defend our claim as a mathematician. Okay, I also like how this mathematician used a model to tell us or to show us the dimensions of both of the containers. One last thing I want to point out and celebrate that this mathematician did is they put numbers in parentheses to show us which ones they were going to multiply first. And so that's a way that they were justifying their thinking. They were justifying it by being so clear so that when we look at their work, when we analyze their work, which we're doing right now, we know what their first step was as a mathematician. So good job. Thanks for letting us share, student 1. And then here we're going to look at another student. Here's student 2. Just go ahead and take a second to look and analyze their work today. One of the things that stuck out to me about the students' work is that they had really clear labels. They said, this is where I'm calculating the volume of the soup container. This is where I'm calculating the bowl or the plastic container. They also had labels to show us that 4.5 or 4.5 was going to be rounded up to 5, and 7.5 was going to go ahead and be rounded up to 8. So that was really clear. So I knew exactly what their plan was as a mathematician. I liked that they showed a model with dimensions. And then the last thing that I really stuck out to me was that they said, I know that the soup will fit because the container is larger. Okay, so they're directly using their calculations to support their claim. So these are my numbers that I'm coming to, and then this is what I think is true. Okay, so my next challenge for you today came to me because as I was doing the work to find the volume of the soup container and then to find the volume of the plastic container, I was having different products than you guys were. So as I was multiplying, I was getting different answers. And so I didn't know if my answers are accurate or your answers are accurate. And so today I'm going to challenge you to find my mistakes. Okay, so I'm going to do some calculating. I'm going to focus in on the soup container. And I'm going to show you how I found the volume of the soup container, but I'm going to make a mistake each time. Okay, so I need you to see if you can find the mistake, and then I want you to look back at your work from yesterday. Did you make a mistake? Is your thinking changing now that we're really trying to challenge ourselves to be precise as mathematicians? How could you prove the calculation or the work that you did yesterday? Okay, so good luck. See if you can catch my mistakes. Okay, good luck finding my mistake. So here's mistake number 1. I'm gonna focus on the soup container, and I know the soup container dimensions are 14 by 8 by 5. So I'm gonna go ahead and start with 14 times 8. I'm gonna break the 14 up by place value into 10 and 4. I'm going to do 10 times 8 and 4 times 8. So 10 times 8, 4 times 8. 10 times 8 is 80. 4 times 8 is 32. Now I'm going to add both of these products together to get my final product. So 80 plus 32 equals 0 plus 2 is 2, 8 plus 3 is 11, 112. So both of these were partial products. This is a partial product strategy, and then I got 112. Now I'm going to do 112 times 5, which is my other dimension. I'm going to do the same thing. I'm going to break up this by place value, 100, 10, and 2. 100 times 5 and 2 times 5. 100 times 5 is 500. 2 times 5 is 10. And then I'm going to add both of these products together to get my final product. 500 plus 10. Man, those are friendly numbers. 510. And then I know I want to do centimeters to say what I'm measuring in, and I'm calculating volume, so I want to make sure it's cubed. 510 centimeters cubed. Okay? That's mistake number 1. Do you think you can see it? I don't know. You better tell me. Here's mistake number 2. Dun, dun, dun. Okay, I'm going to start this time with 8 times 5 because I know exactly what 8 times 5 is. That is so friendly. 8 times 5 is 40. So now I'm going to do 40 times 14. That's 2-digit by 2-digit. I'm going to do 14 times 4. So I'm going to make that 40 10 times less and just make it a 4 because that's going to be so much easier to calculate. And I'm going to break this up by place value just like I did last time. 10 times 4, 10 times 4, and then 4 times 4. 10 times 4 is 40, 4 times 4 is 16. 40 plus 16, so I'll add both of these products together. 40 plus 16 is 56. Okay, so I have 56, I'm measuring in centimeters. 56 centimeters cubed. 510 centimeters cubed and 56 centimeters cubed seem like they're pretty far apart. They're not close at all. Okay, so did you see my mistake there? Okay, let me know what my mistakes are. Good luck.